Good morning, grade 11 students. This is Mrs. Pascal. Today's date is March 18, 2020. Our lesson title is Modeling with Quadratic Functions, Chapter 4, Section 4.3. The objective of this section is to define the equation of a quadratic function. In order to define a quadratic function in standard form, we need to use any given 3 points of this function. Example 1. What's the equation of the quadratic function passing through the points 0, 0, -1, -2, and 1, 6? So to define the equation of the function y equal ax squared plus bx plus c, we need to replace by the coordinates of the 3 points. So using the first point 0, 0, and by replacing x by 0, y by 0, we get c equals to 0. Using the second point, and also by replacing x by -1 and y by -2, we get the equation a minus b plus c equals to -2. But we know that c is equal to 0, so the reduced equation will be a minus b equals to -2. Using the third point, 1, 6, and by replacing x by 1 and y by 6, we get a plus b plus c is equal to 6. So the final reduced equation is a plus b equals to 6. The result is a system of two equations for two unknowns. A minus b is equal to -2 and a plus b is equal to 6. We can solve it by using the calculator mod 5, 1. So we get the answer a equals to 2 and b equals to 4. And finally, we replace the real values in the quadratic function. So y is 2x squared plus 4x. Example 2. A player throws a basketball toward the hoop. The basketball follows a parabolic path through the points 2, 10, 4, 12, and 10, 12. Remember that a parabolic path is a graphical representation of a quadratic function. If the center of the hoop is at 12, 10, will the ball pass through the hoop? To solve this problem, first we need to identify the equation of the curve by y equal ax squared plus bx plus c. So we need to use the 3 given points in order to define the equation. By using the first point 2, 10, we get 4a plus 2b plus c equals to 10. By using 4, 12, we get 16a plus 4b plus c equals to 12. By using the third point, we get 100a plus 10b plus c equals to 12. As you notice, we have 3 equations with 3 different variables. So the result is represented by a system of 3 equations for 3 variables. To solve this system, we need to use the calculator. So we use mod 5, 2 to solve the system of 3 equations, and we get a equal -1/8, b equals 7/4, and c equals to 7. So the equation of the path is y equal -1/8x squared plus 7/4x plus 7. Step 2. To know if the ball will pass through the hoop, we need to replace by the coordinates of the center of the hoop in the equation. So replace x by 12 and y by 10. Since we get 10 equals to 10, so the coordinates of this point verifies the equation, so the ball will pass through the hoop. Example 3. A man throws a ball off the top of a building and records the height of the ball at different times as shown in the table. Part A, find a quadratic model for the data. Part B, use the model to estimate the height of the ball at 2.5 seconds. Part C, what's the ball's maximum height? Writing the quadratic model of the data means we need to define the equation of this curve. So h of t is equal at squared plus bt plus c. To define the real values a, b, and c, we need to write a system of three equations for three unknowns. So by using the previous points, we can write this system. First, use the point 0, 46. We get the equation c equals to 46. Second, use the point 163. We get the equation a plus b plus c equals to 63. Since c is given by the value 46, so we can replace it in the equation and we get a plus b is equal to 17. Use a third point, let's say 248. So we get the equation for a plus 2b plus c equals to 48. And the reduced form of the equation is 4a plus 2b equals to 2. So after solving the system of two equations defined by a plus b equals 17 and 4a plus 2b equals to 2, we get the values a equal negative 16 and b equal to 33. So the function is defined by h of t equal minus 16t squared plus 33t plus 46. To find the height reached after 2.5 seconds, we need to replace t by 2.5 in the equation, and we get a height of 28.5 feet. To define the maximum height of the ball, we need to find the time reached first, so we need to calculate the time by using the rule minus b over 2a. So t is 1.03 seconds. We can take it approximately 1 second. So after 1 second, the maximum height is approximately at 63 feet.